Hi, in this session we will talk about object relational impedance mismatch, and we will try to understand it with the help of some examples. Object-oriented languages such as Java represent data as interconnected graphs of objects, whereas relational database management systems represent data in a table-like format. Java implements the object model and relational database management systems implement the relational model. Because both the models are quite different to each other in the way they represent data, when we load or store graphs of objects using a relational database, we come across 5 main mismatch problems. And this mismatch between the object model and the relational model is called object relational impedance mismatch or paradigm mismatch, which is just another way of saying that the object model and relational model do not work very well together. Let's have a look at this mismatch between the object model and relational model. The first mismatch we come across is granularity mismatch. Granularity is the extent to which a system could be broken down into small parts or components. In an application, we have many granular objects with various levels of granularity. For example, in an e-commerce application, a person is a coarse-grained object because it contains a lot of details about the person, such as person's address, orders placed by him, his billing details, and things like that. So the person object could be broken down into many small parts or components. Another granular object in an e-commerce application is address, which is a fine-grained object because it contains only address-specific details such as street name, city, country, and things specific only to an address. So a coarse-grained object consists of various fine-grained objects or objects with finer granularity. So in an object model, you can have objects with various levels of granularity. But in a relational model, granularity is limited only to 2 levels, tables and columns. So sometimes when you want the data of objects in Java stored in a relational database, the way you design tables in database to store that data will have more classes in the object model than the number of corresponding tables in the database. For example, here we have 2 classes, person and address, associated with each other, but we have only one table in the database to store data for them. So when we talk about Java objects and database tables, the granularity mismatch problem means storing objects that can have various levels of granularity to tables and columns which are limited in granularity, which means that the object model is more granular than the relational model. The second mismatch we come across is subtypes mismatch or inheritance mismatch. We have the concept of subtypes or inheritance in the object model, but we do not have any such thing in the relational model. In the example here, a book is a subtype of product in the object model, but no such thing could be defined in the relational model. The third mismatch we come across is identity mismatch. In a relational database, the sameness of 2 entities is defined only by their primary keys. If they have same value for their primary keys, they are considered identical or same. But Java defines both object identity and object equality. Object identity is being compared in the first one here, which results in false because the ID of the instance foo is referring to is not same as the one bar is referring to. So they're not same. The value of ID here reflects the address of the objects in memory. And object equality is being checked in the second one here, which will result in either true or false based on how the equals method is implemented in the class, instances of which foo and bar are referring to. The fourth mismatch we come across is associations mismatch. Association in object model is achieved by object references, whereas in relational model we use a foreign key to associate 2 entities. And object references are directional. If an association between objects should be navigable in both directions, you must define the association twice, once in each of the associated classes. Just like the example here, but the foreign key associations are not directional. The fifth mismatch we come across is data navigation mismatch. The way you access data in Java is fundamentally different than the way you do it in a relational database. In Java, you navigate from one association to another walking the object graph. What this means is that to find a particular item, you navigate from one object to another, following the associations between the objects until you reach that item. For example, to get the value of y here, you first access the bar object and then only you get the value of y. Similarly, if you want to get the value of z here, you first access the bar object and then the zoo object using the association between the bar and zoo objects, and once you had the zoo object, you could access the value of z. But this is not an efficient way of retrieving data from a relational database. The single most important thing to do to improve performance of data access code is to minimize the number of requests to the database. And the most obvious way to do this is to minimize the number of SQL queries. So, if you want to get data from more than one table in a database, you write an SQL join query to join those tables and then get the data from the joined table. For example, here we have two tables, the customer table and the order table, and if you want to get the data of the name column from the customer table and the data of the order number column from the order table, you first join the customer table with the order table using SQL join query and the foreign key relationship between the customer and the order tables, and then select the name and order number data from the joined table. So you're not writing two different SQL queries to get data from two different tables. You are doing it with just one SQL join query. So these are the 5 mismatch problems we come across when we load or store graphs of objects using a relational database.